We live in a world today where reality is that data is being constantly generated. So Forbes estimated that, in fact, every day there's around 2.5 quintillion bytes of data being generated. That's a 2.5 with 30 zeros behind it. So by the time we end Igloo and the start, there will be 5 quintillion bytes of data generated throughout the universe. And of course, this doesn't help. So like there's data all over the place. And this is a pretty good example, like the data that is being generated and data that is being used, 80% of that data is coming in unstructured formats. So think of PDFs, images, videos, audio files, and so on. So it is estimated that within businesses, within enterprises, so 80% of their data comes into an unstructured format. So as a result, it costs time and money, and then internal decision can become less informed because, yeah, people need to analyze that data, extract information out of that, and so on. So data information really has the possibility to become a burden, or you can make it something that an asset out of it so that you can use it throughout. So, and this is what we are going to try to talk about today on how to extract necessary information from unstructured data. So my name is Glenn. I work at Azure Belgium. As Sacco already mentioned, we do like 100% Azure, I guess. And we have experts all over the place. So that's where we are. So the scenario today is based on a real-life scenario. So it is a data platform for the logistics, and their aim is to be the data platform reference globally. But if you're a bit familiar with the logistics, they kind of have like old ways of transferring data or sharing information with each other, like PDFs and emails. Again, like I mentioned, they have EDI files, they have scans of documents, like papers for the trucks, they come like in scans of pictures. So it's really an issue there on how to extract the necessary information there. So we're based, the demos today will be based on that scenario. To make life more easier for you and to not load you up with all the logistics issues, I've decided to download a set of movie data, images, some metadata about movies, like the title, the release year, the amount of money it costs to make, and so on. And for each of those movies, necessary images of that. So what we will be doing today is there will be a data producer, so a guy who creates data. What he will do is upload images in blob storage and upload the metadata of that movie into CosmosDB. So what will happen then is we will trigger event grid and use the blob created event, and that event will be used to tell cognitive services, hey, cognitive services, trigger your reindexing and do OCR classification of the images that are in blob storage. So once we have extracted that data, we will enrich our CosmosDB document with that data in order to be able to have like one big document with all the necessary information. And what we will do is then present that on the website. And maybe it's a good idea to immediately show what our end result will be. And I want to apologize for my front-end skills, but at least I tried in this case, right? So what we will do is we will search. We will search for aliens, then we will get aliens back, which is good, right? Then we do like something like Monsters, Monsters University, Monsters Inc. Pretty good. But then it becomes a bit trickier. So what we will do is, and this is, cognitive search allows us to do like more semantic search. So if we do like movie with monsters and aliens, and my suggestion gave it away. So what it will do then, it will start to do like more semantic search on top of my data. So we have Monsters University, the Muppets, kind of monsters. So Superman is an alien, I guess. And then we have a lot of movies that probably have something to do with monsters and aliens. Dumb and Dumber, yeah. Yes. So back to the slides. Good. So what we will learn today is we will learn about data enrichment and indexing, how cognitive search is working. We will talk a bit on CosmosDB, a little bit, because Mark covered that yesterday, but we will do something fun. So take your cell phones. It will be super fun, I guess. Let's hope so. And then we will talk about cognitive search and how you use the API to query the data. So data enrichment and indexing. For people, we're in this part where we upload the data, do OCR classification, and then do the indexing of cognitive search. You've seen the slide yesterday from Zachary. And in this talk, we're going to cover the portion here on the left-hand side for you. We will cover the part where we talk about cognitive services, cognitive search, and so on. So what is cognitive services? So cognitive services is a set of APIs created by Microsoft and made available for you. And it allows you to do certain things on top of data. It allows you to do text analysis. There's a great API for speech that does translation, speech recognition, and so on. There's the whole image classification, image recognition, video analysis, and so on, which is the Vision API, and then the decision, which is giving you anomaly detection, and so on. So those are a set of APIs made available for you. So what has Microsoft done? They took those set of APIs and they create a thing called Azure Applied AI Services. And the Azure AI applied services, this is a mouthful, allows you to like do, they wrapped around, they grouped some APIs and they allowing you to do stuff like form recognizer, bot services, and cognitive search is one of them. And cognitive search is a service that groups a couple of these APIs together. You, as a developer, can choose to either work directly with the APIs or contact or work with the Azure AI services to work with the packaged product. So today we're going to use cognitive search. And cognitive search is a platform as a service offering that allows you to do semantic search, keyword search, and so on. But what it basically does, it is making search intelligent. So if we look at traditional search or traditional search within application, you can or you have ingested data, and then you as a developer start writing queries on top of that data. But if you want to do like more, harder searches, it becomes really difficult to create your queries on top of that. And this is where the more AI-powered search comes into play. So we have our data ingestion, and then we have a thing running on top of that that starts enriching the data. And then basically what you can do is do a more semantic search on top of that data, where you really extract all the information you need. So in our case, in the case of our movies, we could have written an API or a website that was probably better than mine, but we could have created a website that searches for movies and aliens only on the metadata. But then I think you would not get that deep result from that. So what cognitive search is doing is actually what is called knowledge mining. So it takes the image and then runs an AI service on top of that, extracting all the information from that image. It does recognition of celebrities. It finds some items within that image, and so on. So you will see that all happening, hopefully, during the demo. So cognitive search has a couple of core components. So first of all, there's the data sources. So it allows you to connect to certain data sources. It allows you to connect to blob storage, to CosmosDB, and so on. And then there's the indexer. The indexer is just a service that is taking a look at your data store, grabbing the recent changes of that, and running that intelligent services on top of that. So an indexer is just a timer. You can run it once, you can run it every couple of minutes, you can run it daily, basically as you wish. And then there's the index. And the index is really the key of your cognitive search. It allows you to, as you will see in the demo, it will give you a complete index of all the documents that, or all the images that are within your data source. And it will apply some things on top of that. There's a couple of features that you need to enable, and I will also show you that and go into details on that during the demo. But these are important to take into account and to know what you want to do with your data. So if you want to sort on a particular field, you make it sortable. If you want to filter with OData style querying, you put that filterable value over there. And so based on those settings, you will start creating that index. So if we take a closer look at cognitive search, again, we have our developer who is ingesting or putting data into the data store that we're working with. And then there's a couple of things going on. So what will happen, it will kick off a sort of process, and it will start doing extraction of the fields and extraction of the data. What you can do then is potentially use an AI enrichment pipeline to call cognitive skills like OCR classification and so on. You can even use third-party enrichers, and all that information then will come back to your index and will be made available for you to query. So this is like the whole API, the AI enrichment pipeline, and it basically ends up with your index and make your data available. So let's jump to the demo. So as already mentioned, we first of all have a blob container with a couple of movies in there. So let's take one. If we take one here, you will see that, oh, Madagascar, nice. So these images are here I know the quality isn't that great, but Cognitive Search can work with it anyway. So then we have Cognitive Search available. And if we take a look here, we have a thing called data sources. And in our case, we have a movies blob. And this is just a connection to my blob storage account. As an ingestion point for my data. Then, as already mentioned, we have an indexer. And you can see here that if I click it open, you can see some of the settings. So this indexer is running at a custom interval of 60 minutes, but you can configure it as you wish. You can configure to run it once, and so on and so on. But the real magic is happening here within your index itself. So if we look at our Azure Blob index, you could, and just give a shout if this is not clearly visible. So this is our index, and this is our main entry point for the application that we will start using. So as you can see here, Cognitive Search, what it did is it created a document within this index, and it contains all kinds of metadata related to my image within my storage account. But what it also did is it extracted some additional information. In our case, it has a location dinosaur, which is pretty weird as a location, but I believe Cognitive Search anyway. So, but what it also can do is it can extract celebrities, it can select other entities, and so on. So what we will do here now is I will run I will not show that website again, I promise. I will run a data sheet, and what that data sheet will do is I will add 6 new movies to my storage account and add the metadata of that movie to CosmosDB. So what will happen if you remember the demo setup? So Cognitive Search will do the entire OCR classification. Once it's done with that, we will take that OCR information and add it on top of our CosmosDB document in order to have like the full information available within CosmosDB. So let's see what this gives. So hello movies, this is a start. So we've inserted like 6 blockbusters. So we have Avatar, I Am Legend, The Avengers, Wolf of Wall Street, and so on. And as you can see, I've also uploaded images to blob storage. So if we would go to blob now, let's go to blob storage to actually prove they're there. This is the most exciting part of the demo. Oh, no, that's modified. Ooh, that was stress. They're there. So that's one thing that went okay. So now jump to cognitive services, Azure Search, sorry. And let us take a look at our indexer. So, and as you can see here, we have our Azure Blob indexer ran a few seconds ago, and as you can see here, the documents that are succeeded were 6. So 6 documents have been added to our index, and OCR information should have been extracted from that. So let's go to our index then. Here. And if all goes well, I should be able to do like, just type the name of the file. I think it was this, right? do the Avengers. And as you can see here, the file or the information is already available within our index. So if we take a look here, as you can see, there has been data. I will just move here so you can see it. So data have been extracted from it. So it's just the metadata of my storage. But as you can see, what it also did is what was extract people information. So it was able to identify Robert Scarlett, Jackson Marvel from the people. So, and there's also some key phrases that it has detected. And what it also did was add some image tags. So based on how the image looked or what was inside the image, it added some tags over there. And then it also added some entities and so on. And all that based on just on the image that was within the storage account, which I can show you. So this one, if I can open this. Open file. So based on the image, so on this, so with just uploading the code, without just writing any code, uploading the image, it started recognizing a lot of things going on within this image. So, and just to show you what happened behind the scenes, or what happened with CosmosDB, is if we go to CosmosDB and we open our movies, we can do a thing like, should use snippets like Stacy, that's smarter. I also cannot type. It's demo, I guess. You can see here that the data is there. And we've enriched, no, let's do the Avengers again. Let's see, that's 300. So here we've just added additional data in our CosmosDB document just to make it available within our document for searching. So, and that seamlessly brings us to our next topic, which is CosmosDB. Now the exciting part starts. So if we're still following, we're here, and I should move that box up. So we're in the CosmosDB area. So, and as Mark yesterday said, so CosmosDB is non-relational by design. It is schemaless and really designed for scale-out. So in order not to repeat things that Mark said yesterday, or not to say wrong things while Mark is in the room, I'm suggesting that maybe let's do a little pop quiz. And I know quizzes on Friday, nobody likes them, but I hope you're a bit enthusiastic about this. I would like you to ask to take your phone, scan this QR code. I'm seeing a lot of phones, awesome. Or go to menti.com and use this code. So I will give you like 30 seconds, stand here awkwardly. So there will be 2 questions there. Some easy questions, I guess. Let's see. If all goes well, I should see the results popping up here. Okay, great. Oh, we have 32 people. Awesome. Great, great, great. So I believe Mark will be happy that a lot of people paid attention. So CosmosDB indeed supports all the models that were mentioned here. It supports key value, it supports graphs, and so on. So the next, ready for the next question, or? Yes? Ooh, wow. Was that the question? Yeah, good one. Next. This actually works. I'm super excited. Great. Next one. So when designing a CosmosDB application, what is the most important concept to distribute your data effectively across into CosmosDB? I know. And Mark just came in, so he can probably validate the answer for me. So what's the most important concept to distribute your data effectively in CosmosDB? It's the partition key. That would be another question. What? All right. Thanks for joining. Awesome. So that was it. So 2 questions. That's not that bad. So indeed, like when you're partitioning, as Mark said, you're basically optimizing for both read and write. So it's and it becomes more critical at scale. And so let's skip a couple of these information. But I wanted to say that, yeah, it's really all about that partition key. So it's really important to get that correctly. In our case, in our movies, yes, this one, as we are doing I believe the data set was a top 15 movies of each release year. Release year was a pretty good option to as a partition key, as you have pretty stable items and distribution over there. If you would have chosen something like genre, and surprisingly, most popular things or genres within movies are action movies. There are some sci-fi movies there, but apparently nobody likes westerns anymore. So an action or genre would be like a bad partition key. So, and I think Mark already covered that yesterday. It's important to think about collocation of your entities just to optimize and minimize your query scope. So it's better to like store your whole document so that you can get all of your data in one go and you can serve it to the application that it's needed. Also think about your indexes and sorting and so on. If you need to run more complex queries, then Azure Cognitive Search comes into play. It's, again, allowing you to do that more semantic search on top of that data within CosmosDB. Important part here, again, as Mark mentioned yesterday, storage is much cheaper than compute. So don't be afraid to duplicate your data and make it, optimize for reads and writes depending on what you need. So there's a couple of things that we need to know if we use CosmosDB together with Cognitive Search. There's a couple of important things that you need to be aware of. The first thing is the thing called the high watermark. So as already said, there's an indexer running on top of that data. So every time you configure it, so once a couple of minutes, it goes and take a look at your data source and see if there are any changes within that. So this is the default query that Cognitive Search uses to get that data. What it does, it takes a look at the _TS, so the timestamp, and it compares it with the @high watermark, and that's just an internal timestamp of the system the last time it indexed your data. So basically, every document that will match this query will end up again within your index. So it's basically just like a detection policy on that data, just to add it to your data or not. Another thing is deletion of the data. So you probably saw when I add documents into my index, that those documents not, if you like, delete it in your original data source, automatically, these changes don't automatically come back into your index. So the data has been added to your index, and they don't automatically synchronize that deletion, or they don't automatically detect that deletion unless you add like the _is_deleted true to your document. So you basically need to implement some kind of soft delete within your document in order to allow cognitive search to detect the changes that is happening within your CosmosDB documents. So if you need to do that, just add the _is_delete and use that soft delete method to track those changes. So let's jump back to the Azure portal and do a demo on CosmosDB. So what I will do is I will run through the process of connecting your data set, creating an index and an indexer in order to index our data from CosmosDB. But before let's do that later. So first of all, what we can do is like start importing our data. So there's a pretty nice wizard if you use the portal. Of course, this is all supported with bicep files and ARM templates. So, but in order not to bore you with me writing bicep, it would be a stupid demo anyway. I will just click it together within the portal. So let's connect to CosmosDB. Give that a name. Choose a connection. Let's do this movie. Should find myself a database. And we can choose this collection. As you can see here, this query, I will open this up. So this is the query that is used from CosmosDB to get your data into cognitive search. And here again, this high watermark is important because that will be your reference point for when your indexer is running. So here you can change this query if you want. So I have a select star now, but you can choose to select only certain fields. You can do all the things that you want, as long as you respect or you include that that comparison with that timestamp in order to get like all the result that you need within that. So next within this wizard, you can add cognitive skills if you want. So what it does for you, it detects the schema automatically. If you want to add cognitive skills or cognitive services, you can add this here within that wizard. You can choose to add enrichment, and as I show you for my for my blobs, you can choose that he starts extracting people names, key phrases, languages, and so on. Because we already did that, we used another process to start enriching that data. We will skip this part. Next part, or the most important part here is, here you need to start defining your index. And as already said, here you can choose what fields will be retrievable, what fields will be where you will be able to sort on, what fields will be searchable, and so on. So be aware that some of these settings are unable to change once that index is created. So for the ease of the demo, I will just select them all because that's easy, right? So next part is you create the index or the indexer. Create the indexer. And we will say that just run it once. So while this is creating and running, I will show you one of the other indexes I have. So CosmosDB. You can take a look at the fields here. So, and as you can see within this screen, I can start changing some information. So I could change the retrievable part, but I cannot change like filterable, searchable, and so on. So these things are unable to change once that index is created. Let's just discard the changes. Go back to the index. Let's see if it has ran. So as you can see, it's indexed our 401 documents, and now the data is available from within our index. So it didn't refresh, but I can assume that that data is available here. So like you can see here, again, so we've indexed our CosmosDB database, and this allows us to query CosmosDB in a more semantic way using cognitive search. So before we go to the last part, there's a thing I want to show you is the JFK files. I don't know if anybody already saw that. So this is an example of, this is a showcase of cognitive search where Microsoft took all the documents that were released regarding the JFK case. So all these documents were made publicly available. And what has Microsoft done? They let cognitive search do its thing with it. And this is like a pretty nice use case of that. So all the documents related to that case, you can now query if you want. So let's search for Mint. Mint2 will be difficult. Let's search for Mint first. So here, as you can see, you will see those information. I see minor, I see Mint. That was great. So again, this all cognitive search is running on all those documents, and the index has been created. You see here that there's certain tags made available, Cognitive Search automatically tagged all these documents to group them together to make some sort of grouping that would make sense. I don't know if there's something like Igloo available. This is probably Finnish for Igloo. Sounds correct, right? I thought so. So this is a pretty nice website to showcase the capabilities of cognitive search and how they can index their entire documents without doing a lot of work. So back to the slides. So, cognitive search querying. So, I also have a quiz for that. No, that was a joke. I will stop soon, so don't worry. So, we're in our scenario here at this part where our data consumer, we've created the index, and now our data consumer, we want to create our search engine website where the data is made available. So cognitive search querying, as already mentioned, the scope for a search is always the index. So as a developer, you will be talking to that index and running queries towards that index. Again, I already showed this image, showed it during the demo. It's important for you to think about what will you query, on what fields will you sort, and so on and so on, in order just to, not to recreate your index. However, that indexing is done quite fast, so it's not a big of a hassle. But important, just think about it. So cognitive search, what is allowed? It allows you to do full text search. It allows you to even do like a geospatial search. It gives you a certain scoring. So if you're running a query on top of that, you get results back. And then cognitive search will give you a scoring on that result, so you know how close you are with the things that you want to do. So how does this work? There's a SDK available, and what you need is you need an indexing client, and you just give that you give it your URI, you give it your credentials, and then you can start creating a search client. So the API also have a lot of things available. As already said, these come back into the configuration that you do from within your index. So if you want to filter on certain fields, you want to do order by and so on. So it's important to take those into account. Once you've done all the settings, once you've created the options that you want, you can just run the search async with your search text, and then you're basically good to go. So cognitive search offers different options to query stuff. So there's the free text search, there's the count, you can do a select, you can order by, you can do filter, and so on. But I think it's just more easier to show it than just show code on a slide. So let's jump back to here. What I will do, I will not show the website. Somebody doesn't like my session, started crying. Sorry for that. It's okay. I will. So I already showed you like the free text search. So movies with monsters and aliens. That should work. So we have Monsters University, Monsters Inc., and so on. Interview with a Vampire. I don't know what monster is that about, but okay. And as already said, what you can do is you can start doing stuff like add a count to that. And count equals true, I guess. So what the count equals true will do is it will give you a count back of all the results that are within your query. So this allows you to do some stuff on top of that, display that on your website, so in order that you can give that user a full experience. What you can also do is do a selection of that. Imagine that we only want to select the title. So this will, again, return a result, but our result will only contain the title. So, of course, you can make that bigger, select a couple of fields that you want, but that option is available. So that's just the OData query. And maybe just to emphasize, you can see here that it adds a search score. And based on that, Cognitive Search is telling you how confident it is with the result. So what you can also do is like do filtering, like and you can say like, I want that the ImageDB rating is greater than 80. And then it will return those only the movies with a rating that's bigger than 80. So 81 is bigger than 80. That's good. And you can also do things like order by and so on. And this allows you to really do like really great stuff while querying that data. I think I already showed the .NET implementation. So this demo, including the pretty awesome website, is available on my GitHub account. So you can go there and see the implementation of the .NET SDK and potentially grab the website for your production use. So what did we learn today? So we've talked about data enrichment and classification, and where CosmosDB is, or Cognitive Services, is a set of APIs that are made available for you. And we've talked about how those AI services allow you to do OCR classification on top of that data. We've talked about CosmosDB, not that much as Mark yesterday, but we had fun during a quiz. And the thing I want to help you remind there is that the partition key is super important. And the key of making sure that your data is tracked for deletion is working with the soft delete, and the add high watermark will make sure that your data is being tracked as it goes along. And then we've talked a bit on the querying. So we showed the possibilities like filtering, selecting, ordering by, and so on. So that leaves me some room for questions. If not, thank you for joining. Thank you for being here.